Here's number 1 on the review. A boat travels from point A to point B at a bearing of south 32 degrees west. The boat then travels to point C at a bearing of south 56 degrees east. Point C is exactly 12 miles due south of point A. How many total miles does a boat travel? So south 32 degrees west, we want to start with a compass just to help us with what direction we're going. South 32 degrees west is this direction, and bearing is towards that y-axis. So let me draw a north-south line. And southwest 32 degrees. So 32 degrees is this angle in here. So from point A to point B. The boat then travels at a bearing of south 56 degrees east. So in here. And the angle will go towards that y-axis. So if I draw another vertical line, and then it travels south 56 degrees east, so 56 degrees is this angle here. And then it says point C is exactly 12 miles due south of point A, so here is C. So our boat travels here along AB and then along BC. We do know that point C is exactly 12 miles due south. So here's 12 miles, and that is opposite of angle B, so lowercase b. We'll need to find C, and we'll need to find A. So we have the angle out here, but we don't have another angle in here, but we could figure that out. We have this line here, our north-south line here with A and C, and this vertical line here at B. So we have both of those are parallel lines cut by this transversal. So we can use alternate interior angles are congruent. So angle A is 32 degrees, and out here is 32 degrees. Now knowing that, we can now figure out the angle inside of the triangle. So straight line will equal to, the angles will equal to 180 degrees. So therefore we can take 180 degrees minus 32 degrees minus 56 degrees will give us angle B, and that is 92 degrees. So the angle B is 92 degrees. So we can find A, and then we'll find side C. So A over sine A equals B over sine B. A equals B times sine of A over sine of B. So this is 12 sine 32 degrees over sine of 92 degrees. And then plugging in our calculator, we would get approximately 6.36 miles. So that is A, 6.36. Next, we need to solve for side C, but we also need angle C. So to solve for angle C, the sum of the interior angles of a triangle are 180. So if we do 180, take 180 degrees minus 92 degrees minus 92 minus 32 degrees, then that will be our C. And so C will be 56 degrees, angle C, 56 degrees. So now we can do C over sine of C equals B over sine of B. So multiplying sine of C to both sides, so we can solve for C. We get B is 12 sine 56 degrees over sine of 92 degrees. And we find side C is 9.95 miles. So now to find the total distance the boat traveled, it's only along the AB and B to C. It doesn't say that the boat goes back to point A. So therefore, we just need to add the sides C plus A. So C is about 9.95 miles plus 6.36 miles. And so that will be 16.31 total miles that the boat traveled. Number 3, a 75-foot tower is standing vertical to the horizon on a hill with a 26-degree angle of elevation. cable is attached to the top of the tower and anchored uphill, a distance of 35 feet from the base of the tower. Draw and label a diagram that represents the problem. Find the length of the cable. So we have a 75-foot tower standing vertical to the horizon, and it's on a hill with 26-degree angle of elevation. So first I'm going to draw my hill. That has a 26-degree angle of elevation. And we have the 75-foot tower. So I'm going to put that here on the hill. And it's standing vertical to the horizon. So just straight up and down there. So therefore we know 90 degrees is right here. And the tower is 75 feet tall. So 75 feet. And then it says there is a cable attached to the top of the tower and anchored uphill a distance of 35 feet from the base. So from the top of the tower, there's a cable, and it is anchored 35 feet from the base of the tower. So 35 feet is this length of the triangle here. Then we can figure out this angle in here. So if the angle here is 26 degrees, and we have parallel lines here, and therefore this angle in here is also 26 degrees. Right in here. And so to find the angle inside the triangle, that would be 90 degrees minus 26 degrees. And that equals 64 degrees. So this angle in here is 64 degrees. What we have is side angle side. And we want to find the length of the cable. So I'll call this uppercase C. And we want to know the length of the cable that is across from C. And this is side angle side. So we're going to use the law of cosines. So cosine equals the square root of 75 squared plus 35 squared minus 2 times 75 times 35 times cosine of 64 degrees. So when you plug that into the calculator, you will get approximately 67.44 feet. In a public park, a triangular region of grass is bounded by walkways. The length of each side of the triangular grass region are 90 feet, 120 feet, and 134.2 feet. Sprinkler heads are placed at the vertices of the triangle. Each sprinkler head can be set to limit its angle of rotation. For each sprinkler head, how large should the angle of rotation be set so as to keep the walkways dry and to conserve water? We want to draw a diagram that represents the problem. So I'm just going to draw a triangular grass region, and there is 90 feet, 120 feet, and then 134.2 feet. So I will call this angle A, letter B, and letter C. So I have side B across, side C across, side A across from the respective angle. So let's solve for angle C first. And I'm going to use law of cosine. So cosine of C equals, and that's going to be a squared plus b squared minus c squared over 2ab. So cosine C is 120 squared plus 90 squared minus 134.2 squared all over 2 times 120 times 90. So I plug it in the calculator, I get 78.0014. So 78.00 degrees is angle C. Then I will find angle B next, and I'll use law of sines this time. So sine of B over B equals sine of C over C. So sine of B equals B sine C over C, which is 90 times sine of 78 degrees over 134.2 equals, that would be 40.99 degrees, or we can say Well, we can leave it like that, 40.99 degrees. And then to find our final answer, actually let me go around it to 41 degrees. To find our final angle, letter A, we can just take 180 minus 78 degrees minus 41 degrees equals 61 degrees. So A is 61 degrees, B is 41 degrees, and C is 78 degrees.